$7 per person and 5 jobs. Yes, if you have one.
Oh my God, they're so tight.
No assignment, so no daily quiz, but I would like you to write the equation of that parabola in transformation form, just to show that we have an idea what was going on yesterday. It's the extra practice page in between examples 4 and 5.
$25 tropical Alley Taylor, large canoe. Stop and pick up your gift card in the office. Nerd versus Jock. Tomorrow, hunting for a victory, ammo and orange.
It was really good.
Run out of time, sign up for Young Life All American Valley Fair. Oh, that's all weekend.
Of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Oh my God. I did. I saw the oh my God.
So we're already done, right?
So we're doing number 3.
You're doing the one that's got the graph on it. Howdy. Now the question is, did you put in context so that you're not sacrificing for the look?
No, yeah, I put in context.
Okay. Just making sure you can see the board.
Yeah.
Okay. Okay, if you're having a wee bit of trouble with that, those are those 2 points, especially for those of you in the back. Can you take a graph and turn it into the equation using all those transformations that we talked about yesterday? Okay. This is probably what you'll see that you have the most experience with. Because Algebra 1, Algebra 2, and now PreCalc, this is the third class you've done parabolas in. What's up?
What's the last one right there?
Negative 1, 0? Oh, this one?
Yeah.
What's that? 0, negative 4, question mark? Right, 1, 2, 3. Nope, it is not. It is 0, negative 27 fourths.
Cool.
You're on the right track. Remember, to determine your stretch or compression, you take how far did it go over how far should it have gone. It's a percent change. Like a stretch or compression is effectively a percent change. So what I'm hearing, most folks are catching this. But we're struggling with that. What? Plus 3, yeah. Yeah, true. How do we deal with the compression?
Go over like 1, figure out how much is supposed to go down.
Okay, and there's no point here, so I go over 2 and down 3.
Figure out how much it was supposed to go.
So normally, if I go over 2, how far should I move vertically?
4.
But I went 3. 3/4. That's it. How far did it go over how far should it have gone? Percent. Just like probability, number of favorable trials over number of total. Yeah. Squiggles, scribbles, and all that good business. What? Yeah, it's reflected. Okay. So, before I forget and people get testy about it, got to be that way. I'm getting there. And yes, I did owe you one from yesterday. I never put it up there. Okay. So, we did a bunch of transformation stuff. We review the transformations to the parent functions. If I can transform the parent functions, I can graph the parent functions in their transformed state. Now I can do piecewise functions as ugly as I want to. Remember what we said with piecewise functions a couple lessons ago? Just graph them all and then erase the parts that don't matter. Because it tells you, hey, this is the graph when you're in this area. You're teenagers, you know about behavioral expectations in particular areas. When I'm at mom's house, I will do this. When I'm at dad's house, I'm going to do this. When I'm at school with my friends, oh hell. Okay? In different environments, you have different behaviors. That's what this is. It says in these areas, in this part of the domain, I'm going to look like this. In that part of the domain, I'm going to look like that. I absolutely hate it, but being autistic means I usually mimic. I've grown up always mimicking behaviors. So I tend to pick up voices, speech patterns, and accents around people that I'm around. I hate this, but if I walk into Runnings or Baumgars, I develop a slight southern drawl when I talk to people. Well, I don't go in there, bless her heart. Y'all know that's like the southern equivalent of FU. It's great. Oh, she's such a sweetie, bless her heart. But, yeah, I pick that up all the time. In this area, you act like this. So what I'd recommend, since you don't get the different color, well, unless you can do pens, but don't do pens because you have to erase them. Light pencil, okay? Light pencil, all three graphs, and then darken in and erase to fill out this is the part that actually matters. Okay, starting with this. Where's Vertex? 0, 0, right? No horizontal or vertical transformations. And it's got a vertical stretch by factor of 3. So if I go to the right 1, I go up 3. If I go to the right 2, I go up 12, right? You take 2 squared and then multiply it by the stretch factor. You know, I was up to like midnight making notes for the class 4th hour that I still haven't done because I procrastinated. So I feel that. 1, 3, 2, 12, negative 1, 3, negative 2, 12. And but I only care about this graph when x is less than negative 1. So how do I change what I just made? Okay. I don't care about it after here. And because it says less than, not less than or equal to, open circle at x is negative 1. Okay. What's that graph look like? Don't overthink it. I have spoken, right? It's just a horizontal line at negative 1. But I only care about it from negative 1, close circle or equal to 4. 1, 2, 3, 4. Open circle. And then I get rid of the rest.
Wait, that's 3.
That's a 3?
No, your distance is 4, but you're at 3. Yeah.
Oh. Y'all, I'm tired. I'm really tired. And finally, I'm going to do orangish. Orangish? Yeah. Where's Vertex?
2.
Well, correct me. There's not a vertex. There's an inflection point, right? So we're going to go right 5 up 2. Right 5 up 2. And that's the inflection point of a cubic. Use your cube steps. Over 1, up 1. Over 2, up 8. Left 1, down 1. Left 2, down 8. 1, 2, 3, 4, 5, 6. God, it's like when Connor was a little baby again. Eyes are burning and swimming. I'm too old for this crap. Oh, I can't be up that late. But again, before I go connecting the dots, where do I care about it? From 4 onward. Oh, swing and a miss. Okay, that's the official graph. Now, I don't know about you, but me personally, I have trouble graphing something if I'm not starting at the spot, right? Whether it's the inflection point or the vertex or the origination point of a square root. I always start at this spot and then move from there. Well, what happens when I start at that spot, but it doesn't matter on the graph, right? So just sketch out the whole thing nice and light, then go back and erase the parts that don't matter, darken in, cover up with a pen, whatever, the parts that actually do. Okay? Like, you've all seen new construction. You know how concrete is poured? They actually have the wooden forms. They don't leave that there, right? That's their framework. That's how they start it. And then once they got the finished product, they take that away. Well, Put your forms on there, get all of your sketch stuff, darken in the part that actually matters, and then erase the parts that don't. Okay? So this is kind of a who's who of functions. I see linear, cubic, rational, quadratic, constant, and absolute value. You see why we say you got to have a C minimum in Algebra 2 before you come up? Because this is all Algebra 1 and 2. But now we're throwing it all in one. This is like leftover day where you make the hot dish out of just random crap that was in the fridge. There you go. Mathematical hot dish. Get them. And remember, too quiet in here. I want you talking. Talk to your neighbors. Argue with them. What the? They actually printed the skull and the frosting? That's hilarious.
Okay.
Are they any good? Okay.
So just like a normal. So okay, and then but it's less than greater than
Two of 8. And that's the
oh, that's this one.
Well, that's why. Okay. Y'all, pick up your pencils for a second. There we go. I knew something was wrong.
So if we put like
Lars, you got a whole chair next to you, dude. Come on. I'm a klutz and a half. I'm like fall on you. Right?
yeah, but I don't want to like start from that. Oh wait, you have to move the acid. But there's no move. I don't know.
There is no translation. So the crosshairs are still on the axes at the origin, but instead of over 1 up 1, it's got a 2 in the A spot, twice as far. Over 1 up 2. Over 2 up 1. Yep.
each one.
Really?
I don't know why that's weird.
Yes, I know. Okay, but x is greater than 2 in your equation. So it's
Right, struggling with lines. That's also why I tell kids to do their ACT right after pre-calc, because we kind of review everything. Kids will go into trig and calc and they get so hyper-focused on that content, they forget how lines and parabolas work. Legit. You know, that reminds me, Lars. Thank you. Semi-related, as we're talking about, 6 different types of functions here. If any of you want for ACT review, I have my old holy sheets from Algebra 1, 2, Geometry, and PreCalc. So, do you remember doing major and minor arcs? Do you remember doing chords? Do you remember doing secant and tangent lines? It's all right there. Okay? So if you would want any of this, I can just send it to you, or I can put it into our shared drive. But really good for review for ACT. Okay, if I were to just throw them all on here, x minus 5. Trying to do it without making points. There we go. And x cubed. And 2 over x. 1, 2, half, half. Okay, it's just kind of this snarl of different stuff. But you look, where does it actually matter, and then erase the rest. I see this only matters when x is less than or equal to 0. So solid dot off to the left. This only matters from 0, open circle, to 2. So open circle, got to get my, there we go. And then close circle. This is like the perfect color for tomato soup. And this one, when x is greater than 2. So an open circle when x is 2, and then follow that one. So if that's the part that matters, then I'd come back and erase all of this little stuff that doesn't matter. Oh, still got one of those. Right. Come back and erase everything else because it no longer matters. And there's your graph. Okay? Did you get it?
Yes.
Cool. What about contestant number 2? I got a parabola that is translated left horizontally, 6 units. Regular perfect square steps, 1 squared is 1, 2 squared is 4, 3 squared is 9, reflected across an axis of symmetry. Try to keep it curvy. Eat some potatoes. Just horizontal line, 7. Womp. The constant function. And, all right, how many of you caught this?
Oh.
Separate b from x minus h. So it doesn't move. It doesn't move left 4. It moves right 4. Okay. Now remember, if I have no idea how to graph something, you can always graph by table, right? Just put that into y1 and go look at the table of values. But I was actually just doing this with algebra 2 the other day. You know that you can now separate that as a -1 times absolute value of x minus 4? And the absolute value of -1 is just 1. This is why we rarely saw b values in Algebra 2 because the B value can be turned into an A. Absolute value of -1 is just 1. There's still an absolute value. It's still going to be the V. Now, right here, yes, there's a B value of -1. Remind me, what does a negative in the B spot do? What direction? Over the y-axis, vertically, right? What happens when I take a V that is already symmetric about its axis of symmetry and I reflect it horizontally? Absolutely nothing. That's why we rarely saw that, because it could be turned into an A value of 1. So regardless, that thing is at 4 absolute value. I don't think he's okay. He doesn't feel so good. Then we have ba-dum-bum. I only care about this one when x is less than -5. So I come to -5, open circle, follow the yellow brick road. I'll get rid of the rest. I only care about this one between -5 and 2. So come up to -5, closed circle all the way over to 2. I'll actually go to 2 this time, close circle. And I care about the V after 2. So open circle, follow the V. Then you come back and get rid of that, and get rid of that, and get rid of that. Poke, poke. There she be. Did you get it? Okay, that's it. That's graphing piecewise. If you are good enough to just look at this, know that it's going to be here, look at the domain and say, okay, I'll only graph that part of it, great. Go for it. If you're not, graph them all, erase the parts that don't matter. So, all right, transformed functions. So, blah, 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 word problem context. Okay. Path, 60-yard punt can be modeled by this particular quadratic vertical distance is y, x, or g of x, I suppose. X is horizontal distance. X equals 0 corresponds to kicking from the 20-yard line. Okay, y'all know how, not everyone knows. Y'all know how football fields work, right? In the middle, the 50-yard line. In between, 1, 2, 3, 4. 1, 2, 3, 4. From here to here. From end zone to end zone is 100 yards, but the end zones themselves are 10. So the entire field is technically 120 yards. They're saying that we're going to make a function here that says we're all the way back on R20 and going to punt the ball, sounds familiar, where horizontal distance, vertical distance. Okay? So that's how it's working. And that's my function. Describe the transformations. Well, how am I going to describe the transformations if it's not in transformation form? Make it transformation form. If g of x is -1/15 x squared plus 4x plus 1. Here, let's big. There we go, big. I need to transform that into transformation form. Transformation form has a item squared. So all the way back to Algebra 1. You saw it again in Algebra 2. You keep forgetting it because as soon as we tell you quadratic formula, you forget it exists. Complete the square. Okay? Okay. First, I'm going to take that plus 1 since it doesn't have a variable. Remember, we always did variables on one side, constants on the other. Well, I don't actually want to subtract the 1 over here because it belongs on this side. So I'm just going to kind of shove it off to the side, out of the way, so I can make my perfect square. Then, remember we always divided by a, eliminate the Canadians, right? I'm going to take that negative 1/15 out of both of these terms so that I can complete the square. Well, negative 1/15 divided by negative 1/15 is 1, so this is just x squared. What is 4 divided by negative 1/15? Negative 60. Dividing by fractions is easy as pie. Okay, so negative 60x. Now I need to complete the square. I complete the square by adding, does anyone remember? B over 2 squared. What is B right now?
6, negative 60.
Negative 60. Half of that.
Negative 30.
Negative 30 squared.
Big number.
900. So I'm going to add 900 here. Look at where it is. In the parentheses. Did I really add 900? I added whatever negative 1/15 times 900 is. So what is negative 1/15 of 900? Close. Negative 60. So if I subtracted 60 on this side, normally we would subtract 60 here, subtract 60 here, right? But I want it on this side. So I will instead add 60 on the outside to balance out what just happened. So you get what's happening here. I'm completing the square in here, but because of A, this is why we always eliminated the Canadians. This is why we always divided by A instead of factoring. Because if I leave this out here, it messes with the process, right? I have to think, I'm not really adding 900, I'm really subtracting 60. That's why we always divided by A, so that we didn't have to deal with this. So adding 900 in here allows me to say x minus 30, the quantity squared. I didn't really add 900, I subtracted 60, so I add 60 out here to undo that. And I get a parabola such that my vertex is up here at 30, 61, and it has a vertical reflection and a vertical compression by a factor of 1/15. Okay? So the transformations, well, we just set them. I have a reflection in the x-axis, or vertical reflection. I have a vertical compression by 1/15. I have a horizontal translation, bass-ackwards land, right 30, and a vertical translation, up 61. To which I go back to that original lame drawing here. Remember we said the end zone, and then they said they kicked from the 20-yard line. If this is the 20, do you see why it was a translation right 30? Because the end zone is also 10. Okay. You can tell that it was a bunch of like crotchety old white dudes that wrote this book because they just assume people know football fields. So, then after getting that, y'all remember finding the vertex of the parabola? We reviewed like 2 weeks ago. Negative b over 2a gets you axis of symmetry. Right up here. What's b? A. What is that? Get the calculator if you need to.
I'm guessing 30. Oh my gosh.
Because it's the vertex, that's the transformation. And then go find g of 30. Take a wild guess what it's going to be. How about 61? Because that's my vertex. All right, then I go and make you real mad. Y'all got your calculator? Negative 1/4? No, it was 15th. X squared plus 4x plus 1. Window. I'm punting a ball across a football field. A reasonable window would be, well, they said we're starting at the 20-yard line as x equals 0. So I hope we don't go backwards. Although, from there, another 100 yards. And how high will this thing go in the air? I don't know. How high do you think you kick the ball in the air? Okay. I'll just say another 100 yards. Maybe you just have one of those. I just put in the function. And we get parabola. A very slow parabola. One of my alternate email addresses has parabola in it, and customer service doesn't know what a parabola is, so they say parabola. Hey, that looks like it has a maximum. Somewhere between 0 and 50. Come on. Come on, Frank.
What the heck? Frank is me. Is that his name was?
No, it's Frank. Wow, that took forever. But, y'all, if you know what the vertex is, couldn't you then write it in transformation form? You just got to remember that A is the same whether it's in standard or vertex form. So, hey?
It's just weird that my calculator says 30.00000.
Okay. No, that's legit. I think we talked about that. Why does the calculator sometimes say 30.0000005 instead of 30? Round off error. When I put Blinky in there for the left and right parts of the, sometimes you're going to get a tiny round off error. Like if I was trying to find the zeros of a thing, it might, instead of just saying 0, what happens if it says that? I tried to find the zeros and it said this for my y value. What is this? Really, really little number, right? This is 0.14 zeros 172. Well, that's 0. But it's a round-off error because the calculator is actually using an algorithm. Okay, suppose the punt was from the kicking team's 30-yard line instead of 20. How do I change this function? If this is we kicked from the 20-yard line, how do I say from the 30-yard line? Minus 40. Right? I'm just going to move 10 yards further to the right. That's it. So it's just blah, blah, blah. Hey, word problem. You can still do transformation stuff. So blah, 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 blah. Here's word problem. Do transformation stuff. It has a fraction and a square root. Come on, you can do it. It's actually super easy. Try it. No.
He's gone now. Was he in here trying to learn? I think he was.
No, Officer Gillette is making a point of trying to be in more classrooms this year, just so kids know him and know his face, and you're not freaked out when the cop comes and sits in your classroom. Okay. Yeah, Gillette's pretty cool. Okay.
I was like, when is he gonna force us? What?
No, he's gonna start doing more classroom sit-ins and visits like our administrators do, just so kids know who he is and aren't weirded out by him.
Taylor, was he gonna take you because you have those guns loaded?
Bum. Come on, do the problem. Do the problem. That was D tier dad joke right there. That was perfect.
I'm not doing anything, okay? I know how to use a graphing calculator, I'm just using my resources.
Yeah?
Get in and say you can.
I want you to. Are we already there? What if I went all the way back to algebra half and rewrote that as 1/11th x? Now, I could turn it into an A. I'm asking what is it right now? Okay, right now it's in the B spot. So what happens when I have a 1/11th, a fraction less than 1, in the B spot? What transformation is that? It's a horizontal something. Go back to the Holy Grail that we put up yesterday. It is a horizontal stretch by.
No. Is this in the B spot?
1 over B, the reciprocal of it. It's a horizontal stretch by a factor of 11. Think about it. I'm taking my input and multiplying it by 1/11th. If I cut my input by 11, doesn't that mean that it takes 11 times longer to get where I'm going? Okay. So, your transformations. Horizontal stretch by factor of 11. Reciprocal. The resistance is now 15 ohms. What's the new function? That's it. I just replace this with 15. If I read the original, it said 11 is a resistance in ohms. Well, replace 11 with 15. Graph them both on the same graphing calculator screen. Y'all, a normal square root looks like this. 1, 1, 4, 2, 9, 3. This is 1/11th of that. So now it's going to be 11, 1. I saw a couple of you looking at your calculator and like, ooh, that's tiny, right? It's really squished because we took that graph that should have been coming out like this and yanked it all the way 11 times wider. Okay? So blah, 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 I can do transformations. All right, this is a transformation you did not see in Algebra 2. Absolute value. If I absolute value a function, remind me, what is absolute value? Distance from 0. 4 is 4 units from 0, but -4 is also 4 units from 0. So whether I absolute value an entire function or just the input is going to have different effects on my graph. Okay, you can see it right down here, but if I say y is the absolute value f of x, remember, the function of x is to do this thing to it. So this is the function rule. They're saying if I put absolute value on the whole honkin' thing, well, the whole honkin' thing is my outputs. So they're saying whatever you put in for x, the output will be positive. So if I put in a 4, I get a 2. If I put in a -4, I will also get a 2. Okay, we already knew that. It was parabola. But now, if I put in a 1, I get out a -1. If I put in a 1, I get out a -1. Well, what happens when they can't be -1s? Because they're absolute valued. Now they're positives. So for these, you take everything in quadrants 3 and 4 and reflect up. So everything that's below the x-axis gets flipped up. You get to like mathematical table flip here and say everything down here is actually going to come up here. Actually, here we go. Try to kind of match. But then, since all that stuff is above the x-axis now, you got to get rid of this. Okay? So if I absolute value the entire function, everything comes up above the x-axis. If, on the other hand, if I absolute value just the input, that means when I put in 4, I get this. When I put in -4, I'm still getting this, right? Because the -4 is getting absolute value. The input is being turned positive. So when I put in 2, I get 0. When I put in -2, I will also get 0. Because absolute value of -2 is 2. When I put in 4, I will get 2. When I put in -4, I will also get 2. So you have here everything on the right side is overruling everything on the left. And this no longer exists. This is like alternate timeline Loki variant thing here happening. Okay. You have one side rewriting the other. So that's the rule that we're going to write on here. if we absolute value just the input. That means right side mirrors to left. And it overwrites it. Okay, maybe the mathematical equivalent of, yeah, but mom said I could go. All right. Don't do that to your parents, that's mean. So, they say use this to graph each of these functions. So, first, let's get bigger. There we go. We'll just sketch graph because I forgot to actually put the graphs on here. Whoa. That's also why you should use graph paper. Okay, if I absolute value the whole thing, what's the rule? Everything that was down comes up. So it did come down here and make this little loop. That loop is going to happen here instead. Okay. And then this comes up, and it was going to head down here forever. Instead, it's going to head up here forever. Everything that was down here now comes up here. Everything that was here now comes up here.
I was so confused where you got that from. I didn't.
No, there. Okay. Well, you don't have to be great. I mean, as long as it looks like Aunt Betty fell over and can't get up, you're good. Okay?
Oh my god.
What about, now I get the image of like some gal in a moo-moo like in Walmart parking lot going, I absolute value just X, not the whole thing now, only the input. What changes? Whatever is on the right mirrors over to the left. So this is still here, and then it mirrors. Okay? That's it. If your graph turns into a Rorschach test, it's probably not a good graph. So, I see my mother opening an umbrella indoors. No. Okay. Instead of, this wants you to do both. It wants you to do absolute value of the whole function and absolute value of just the input for both of these functions. Let's split it so it's not so messy. Do the absolute value of the whole function for this guy. Do the absolute value of the input for this guy. Okay? And remember, it's just about mirroring things.
I'm a nerd. I don't know what this means.
Okay, seriously.
It's just like that. It comes up like a peak. Yeah, don't meet something. Yeah. They're all so close.
Well, this part
Like
is
you said, it's like, what do you say? Yeah. You see what I mean?
Yeah.
Yes. Yeah.
Oh.
You still go.
I'm with you.
Yeah. You did. Is there just a hole in here?
Gonna say as well. But then, these ones are missing.
I'm not always right. You know, right?
Wait, does it go like this? Yeah, it's tiny. That's what you said.
Yeah, if you do part B correctly, it should look kind of like a ziggurat. Aztec pyramid.
Oh.
Awesome, like
Thank you.
magic.
My example, and definitely crediting me as well.
It's very close.
What do you do with like the top half of it? How does it just?
It gets overwritten. The right side overwrites the left. The left doesn't exist anymore.
Okay. So.
That's just not there anymore. Poof.
So we do need this one. Does that look right to you?
Yeah.
Cool.
All right. Looks like we're getting it. Okay. To absolute value the entire function, that means, wait, wrong way. Everything that was below the x-axis now comes above the x-axis. So if my asymptote was previously at 4/3, that's not affected. This is just coming upstairs instead, and this doesn't exist. Okay? Shoot. Whatever's downstairs comes upstairs. This one, if I absolute value just the x, that means when I plug in a -2, I'm not getting this result anymore. I'm getting this result because absolute value of -2 is 2. Give me whatever I had at 2. So it takes everything on this side of the graph and it mirrors it over here. Now the way that looks, kind of interesting. Shoop, 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 shoop. Is you get this kind of wishbone in the middle there, right? Because it mirrors. This graph is almost right. What does your reflection look like when your face is pressed up against the mirror? The exact same thing, right? What happens when you have a point that is directly on your line of reflection? There's literally just a point hanging out there.
Yes. Oh, you little fade.
Okay? My wife sent me a picture. They opened the Halloween tree today. Yeah. Halloween tree. She likes Halloween 90 times more than every other holiday in the year. So, okay, A, we were okay with piecewise? Anyone have issues with it other than just not liking doing certain functions? Were we okay with the absolute value thing? Show me thumbs. Honesty thumbs. I get this. One more, be safe. What the? Okay, we're gonna do one more. One more. Absolute valued the entire function. What does that do? Uh-huh.
Wait, are we done with this episode or are we going on to 1-6?
Oh, we're going on to 1-6. We still got a half hour left.
Yeah, I just didn't know.
Ah, no. Every time that I just blow off a half hour in class, it takes away from the end of the year having time to review for our final. And it takes away sometimes all the way into chapter 10. You don't see sequences and series, which are incredibly easy. You get a sequence or series problem on your ACT, you get a 35 instead of a 36, and then you're bitter about it for the next 20 years.
Yeah, that'd be
So you seem to have some prior
Yeah. I do, because I don't want it to happen to you guys. It was literally, I forgot what sigma meant.
When we took the pre-ACT, I missed 2 math questions.
Yep.
I was fried because I was like, okay, so basically just
I think it was like for this class and
Yeah. Because that's how ACT is run. They, like, 80% of it is algebra 2 and below.
yeah.
20% of it is a grab bag of everything from PreCalc up. And the difference of one question can be the difference between 1 or 2 entire points on your composite score.
wait,
So,
no. It's just a parabola. What were you doing? I was about to say.
so this says I will translate to the left 1 normal cubic. 1 cubed is 1, 2 cubed is 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. So this is what it was. This is what it was. What happens when I absolute value the entire thing?
It turns into a parabola.
Not quite a parabola. More like bolos horns. This comes up here. This comes up here. Effectively, you get a negative cubic this way.
So it's like a mixture of
Okay. Question.
So it almost, literally, if I extend this down, it's like a wishbone. Okay, so it's going to have this outward curve at both spots. So,
Don't you, okay, when like x is really small, is it like really close to 0, right?
approaches 0, yes.
Yes, okay. So then wouldn't it just be like a normal curve?
No. If I zoom in on that from so this cubic, if I have a cubic going this way, and I have a cubic going this way, you get this little point at the bottom where this one is supposed to be, wrong way. There's this like little V right here. So it's kind of like almost a parabolic shape, but then it pinches at the bottom because it's 2 cubics mirrored back to back. If you make it really bad, it looks like a parabola.
Give me a sec.
It's supposed to have a little point to it.
looks like a parabola. That is a harmful parabola.
You know what? I'm not going to give this any more attention.
I don't know, man.
Parabolas move in squares. This moves in cubes.
Okay,
If
we
you-
guess it moves in cubes, but it looks like a little.
Yeah, it looks.
It's just cubes. There's no point.
Just listen to him. He's the one that can have that.
Okay. Function rules are expressions. If a function rule is an expression and I can add expressions, then I can also add function rules. I can also do it with subtraction, multiplication, division. This was in chapter 6 of Algebra 2, where we said, here's a bunch of functions, can you add, subtract, multiply, and divide them? Pretty simple. Whatever the rule is, you replace f and g and h with that rule. If this says f plus g, I will take the f rule and add it to the g rule. If this says f minus g, I will take the f rule minus the g rule. Oh, that's h. Oops. Green. Okay. F plus g of x, f minus h of x are literally just this rule minus that rule, this rule plus this rule. I take the f rule plug it in. I take the g rule, plug it in. I take the h rule, plug it in. Oh. Combine like terms, simplify it as best possible. So the first one ain't pretty. It just stays x squared plus 4x plus square root of x plus 2. And then it asks for its domain. What are the 3 commandments that we know already of domain? Dividing by zeros, even roots of negatives, logs of non-positives, all not allowed. What up here is about to break the rules? Okay. So I have to make sure that this is going to be 0 or greater. Set the radicand, x plus 2 equals 0, get x is negative 2, is my breaking point. So from negative 2 to infinity, this thing's okay. Contestant 2, please remember to distribute. Say that's x squared plus x plus 5. Do I have a x on denominator, an even radical, or a logarithm?
No.
So, who's allowed to the party? Everybody. Okay. So it's just playing around with the function rules. This should be, for those of you who just liked, I miss algebra when it was just moving letters and numbers around. This should be your jam. Okay. If I multiply and divide, on the other hand, I got to watch out. If I take the f rule, well, that's this entire rule times. If I take the f rule, that's this entire rule. The h rule, right? The h rule, the h rule. Multiply of x is divide of x is, and I plug them in. And I say the h rule is 3x minus 5. The f rule is x squared plus 4x. Simplify it if you can. The first one, just distribute, combine like terms. X cubed minus 3 plus 12 plus 7x squared minus 20x. All right. Because they'll have a negative 5x squared here and a plus 12x squared here. Oh, I missed the 3 entirely. There we go. Okay. Missed one. Getting there. 14. 25. 25. Okay. This. Negative 5x squared plus 12x squared. See, I am demonstrating what happens when you don't write it out. You make little goofs. When in doubt, write it out. Now, this one, domain, because it's a polynomial by definition, its domain is all real numbers. Like, that's actually one of the defining characteristics of a polynomial. It is continuous for all real numbers. All right, who's not allowed to the party? Okay, negative 4 and 0 are not allowed to the party because I can't divide by 0. So, remember how to write this interval notation? Negative infinity to negative 4, can't touch us. Negative 4 to 0, can't touch us. And 0 to infinity. What? What do you mean solve that? Can you simplify that? Okay, every time I run into a rational expression, I need to see, is there a way that I could simplify this? If I had 3x minus 5 over x and x plus 4, is there any way that I can simplify that? Not right now. But what if that wasn't 3x minus 5? What if that was 3x plus 12? 3x plus 12 over x squared plus 4x would not be the final answer. Because it would be 3 over x. So you know what? Make a note to yourself. Every time you see a rational expression, factor. Now, the final answer is still this. Don't write it in its factored form for your final answer. Because the factored form has parentheses. Parentheses imply there's still an operation to be done, not simplified. But you factor it to see if you could cancel something, if you could simplify it. Curious on this one. What's the domain?
Well, 4 can't. Negative 4 is not.
What about negative 4?
So I'm saying negative 4 cannot happen.
Still not negative 4, because what happens at negative 4? A hole in the graph. So even though my final answer would be 3 over x, this is still the domain. Because there's a hole at negative 4. Okay? Now, that wasn't the case. It's just something good to talk about. So, I can add, I can subtract, I can multiply, I can divide with functions. Which one do I want? Oh, yeah, this guy. That one. You like horrible fake accent?
I do.
All right. All four, add, subtract, multiply, and divide with those two functions. Tell me the domain of each.
Are we doing these, or can I take up the whole space?
Just start with A for now. I don't know. I don't think we'll do B.
Well, this is gonna take up a lot of space, so I really don't want to do this. But I don't write very
Dude, I don't know why.
Okay, so.
Mr. Sullivan has that stuff
Okay,
in my
let's
head.
see the first one. So F plus 2. Because you can't.
You just add them.
Yeah.
No one knows.
Yeah, so this is
Just put the plus mark between them.
plus mark.
Turns out it's as good as that one.
Wait, oh, it's not my
He's on me live.
Oh, I was gonna say. Okay, so it's Wait.
I'm going to solve each equation before I find. You sound like Groot. Yes, me like Groot. That is the accent I use. Girls. Girls like girls. 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 I am Groot. These are my girls. Girls. Agnes, Edith, and Margot. Straight fireball. Girls. Girls. Oh, dude, there's one where it's like, he's like, there's like this cavity in my tooth that could only be filled with children. That's the perfect time to record. Oh my god.
No.
Oh, I love Paul so much.
So.
A little bit, maybe, guys. I'll do the dance.
Who I need to hit?
I got the batteries in the gun. Whoa, whoa. Alright.
Got me one class. You have a gun?
No, I have a toy. I have a Nerf gun for game club, and we usually like shoot each other with it. So basically, when someone's acting really, really wrong in game club or lunch or Spartan time, they might get a Nerf ball. Yeah, we actually used to use it for review games. I'd like draw a target in the back, and you'd like from the back, and you'd hit, and whatever thing you got, your team got points, answered question, blah blah blah. But if I have F plus G, I can't really combine terms. It just stays x plus square root of 9 minus x squared minus 4.
Wait, no, can it turn into 3 minus x?
Oh, no, it can't.
Oh my gosh, I did the wrong one.
Because this is 9 minus x squared.
Oh,
Remember, I can only take factors out of radicals. This is a difference. Now, if this was 9x squared, now that they are being multiplied, now I can take that out. But because it's a difference, the only way that comes out is if I have 9 minus x, the quantity squared, because now it's 9 minus x times 9 minus x. Only factors can come out of radical land.
well, I did every single one of those wrong.
Ruh-roh. F minus g, x minus square root of 9 minus x squared minus 4. F times g is pretty ugly. It is... Shut your hole! Stop flapping your noisemakers. You just have to distribute x minus 4 to the radical, right? X times the radical, negative 4 times the radical. Just stays ugly. If I divide, you cannot leave it as x minus 4 over the square root of 9 minus x squared. No radicals downstairs. They stir up the girls, give them bad ideas. I need to take this times 9 minus x squared. Okay.
Wait, would it be plus x squared or minus? Is it like the opposite?
Square root of 5 times the square root of 5. This is just a radical times itself. This, if it was 9 minus square root of something, then I would need the conjugate, 9 plus square root of something. But because it's just radical, it's no different than if I just had a square root of 7 on the denominator. It's a single radical. So that one's extra ew. Extra ew. This one has x square root of 9 minus x squared minus 4 square root of 9 minus x squared all over. When I take a radical times a radical itself, it's just 9 minus x squared.
Oh my gosh.
Okay.
All you needed was just the last answer to the F times B.
Yep. So, now, domain. This one. Who's not allowed to the party? First one. Okay, I can't take square root of a negative. So I'm first going to find out what makes this 0, because that'll be my break-even point. 9 minus x squared is 0, 9 is squared, x is plus or minus 3. Okay.
Sorry. That's my bad. I'm done. I'll sit here quietly.
Am I allowed to be outside the 3's or inside the 3's? Really? Put a 4 in there.
Oh wait, just kidding. Inside.
Inside the 3's. So this has a domain of negative 3 to 3. Because if I put a 4 in there, 9 minus 16 is now square root of negative 7. I have broken math. Same here. Same here. What's different for this guy? You have to remember that the original had that on the denominator. I can't have 3 exactly, because if I put a 3 here, 9 minus 9, can't divide by 0 unless you're Chuck Norris. So we're going to have a negative 3 to 3. Okay? Suppose I should stop saying that. Y'all are too young and don't even know who Chuck Norris is. Okay, you have been properly educated by your parents, though. You know. Meaning they're the same rough age as me, so they forced you to watch all the same movies. Yes? No? Oh. Okay. Oh, God. Okay. Never mind. They have failed you miserably. Okay.
Have you guys never heard like those Chuck Norris jokes?
Okay, Chuck Norris was like one of the most prolific martial arts action movie guys of the 80s.
That was my bad. I deserved that. I will admit that now.
Just finish this one off. Plus 20. For a reason.
Oh, got it. Oh.
Add, subtract, multiply, and divide.
Following students to the office: Adrian Knopfus, Brennan Walsworth, Aiden Risley, Ruben Lothario.
Can you cancel?
Chase Hayes, Hayden Goodson,
No.
Landon Strand. Please come
Gotcha. Okay. Your homework will just be 1-5 because we finished that off. So it should be accurate on plan book right now. And then when you come tomorrow, we'll finish 1-6, and that'll be the homework. So. Oh yeah, tomorrow's Wednesday. Okay, so we'll cut it off there, and then we'll do quiz tomorrow, and then finish 1-6 on Thursday.
We have a quiz?
Yeah, quiz.